Hello and welcome back to another video session of Introduction to Unity Games Development Part 11. In this session you will learn how to scale a game object and how to create or instantiate new game objects in Unity. Let's head back to Unity and work on this task. You remember in our last session we have attached the cube script to our cube game object over here. First of all, we need to remove this cube script from the cube game object, because what we are interested to do right now, so we will be creating a new script and this script will be attached to the cube game object, and once we play our game at runtime, the scale of this sphere game object will be increased. So what we will do first, we will remove this script from the cube game object. So first select the cube game object, go to the inspector window and click on these three settings button and click on remove component. So the script has been removed or detached from the cube game object, and now we will be creating a new script over here. Right click in the script project window and click on create and select the second option, C# script. So once we create the script, we need to rename this script and I'm going to call this script as scale, because this script is going to handle the scaling issues or scaling options in Unity. Press enter to register this name. So once the script is created, we will open the script in Unity editor, in Visual Studio Editor, and we will be making some changes. Before making any change into this scale script, first we need to attach this scale script to our cube game object. So drag and drop on cube game object. So you just make sure that the script has been attached to the cube game object. As we can see over here in this inspector window, the scale script is attached to cube game object. Double click on the scale script and make some changes. As you can see, the script is open right now and we will make some changes. So here we will be declaring few variables. First variable will be to get the reference to our sphere game object. So get the reference to sphere game object to scale it. So public game object, this variable is going to be of game object type, and I'm going to call it here sphere object, and with semicolon. Right, now we will be creating one more variable of type transform, and this transform game object or variable will help us to scale the sphere game object. So public transform, and we can call it here scale object. Now here in this particular scenario, we will be creating or we will be invoking the awake function in Unity. As you remember and discussed in our last sessions also, awake is basically called when the script is not enabled, or awake is called once there is a confusion that which game objects loads first, and to avoid this confusion we use the awake function. So the awake function is very useful when all the objects are initialized, and then we can use or we can make use of these objects in the start function. So let me call this awake function here. And remember, the awake function is called before the start function. So here is this awake function. So what we will do, we will get the reference to our sphere game object and then we will scale it. So scale object, scale object is equal to sphere object dot get component, and we are going to get the transform component. And remember, the transform component is basically required in order to scale the sphere game object. So once we get the reference to this transform component of sphere game object in the start window, once our project loads or the game is ready to play, at that time the scale of this sphere game object will be increased over here. We got the reference to the transform component of this sphere game object and we saved this reference to the scale game object. Let's go to the start menu, or the start function, and make some changes here in order to increase the size of sphere game object. So here we will call again scale object dot local scale. So we are working in the local system, so local scale should be increased to something, whatever the values we change or whatever the value we insert over here. So new vector tree, as we discussed in our previous video sessions also, the transform component basically takes the vector tree information, and this vector tree will take three components from us: x-axis, the value for x-axis, the value for y-axis, and the value for z-axis. So what scale we want to give for x-axis? Suppose I want to give 1 meter scale on x-axis, 1 meter scale on y-axis, and 2 meter scale on z-axis. You guys can change the values as per your requirement, and you can see the output. So let's save this work and head back to Unity and play and see the output. Let me save the work. Now before playing this game, first we need to attach, you remember we created in the script, scale script, we created two game objects and it is going to ask me the reference to those. So the first one is the sphere game object. So take the reference, drag and drop it over here, and the transform, as you remember in the editor, and for this scale object we will leave it as it is because we are already initializing it in the awake function. So let's start this code. So let's run this code and see the output. When we started this video session, I showed you that how the sphere looks when the game. Initially when we started to record this video, I showed you when we run this game, the sphere will remain the same size. But this time when we run the game, the sphere size will increase to 2 meter on z-axis and 1 meter on x and y-axis. So let's run this game and see the. As you can see, the scale of this sphere game object has been increased, and this sphere looks like an oval shape right now as it is increased 2 meter on the z-axis. So you can play with these different options and you can try how to scale different game objects. The next topic which we are going to discuss is how to instantiate or how to create a game object at runtime. So let me stop this and open the script, and now we will create another object over here, which is going to be the target. And the target, let's suppose if you are interested to create a cube game object, then cube will be the target. Or if you are interested to create a sphere game object, then the sphere will be the target. Now in the start method, we will create a target game object. So we will call this instantiate function instantiate. This instantiate function takes three parameters. First one is the target. What is going to be the target? Next is the position. What will be the position of this target? Like where you want to display this game object, and what will be the rotation of this particular game object as well. So the first parameter we have already filled, which is the target, and this target we will create the reference to this target as well. The next is the position, where you want to display this target. So we are going to create a new vector tree over here, which is going to take the position of this game object. So the position could be, in my case, I'm going to call it on x-axis 1, on y-axis 2, on z-axis 2. That is going to be the position, comma. Then last option is what will be the rotation over here. What is going to be the rotation? By default, you can use the none, or you can give a default according to the local scale. You can give the rotation, and to give this default rotation, you need to call this function, which is called quaternion dot identity. Now this quaternion dot identity will take the default location or the default rotation for this game object. So let's save this script, and we will create a link to the target game object, and once we run the game, we will see a new target game object will be created. So we need to link this. As you can see, the target, it is asking for the reference to the target. So we are going to link the same cube as a target. So it is going to generate another cube game object in our game. So let's run and see the output. As you can see, another cube game object has been created over here. And why we are seeing, or why we are looking into this type of you can say the lighting of this game has been increased a lot. It is more brighter than before. The reason is we have already attached a lighting component to our cube game object. So it has created a clone to this cube game object. That's why the lighting has been increased. So remove this lighting component from the cube game object, and you run your program again. You will get the perfect output without additional lighting shown in the game. So try all these things, and I'll see you in the next video.